In this series, I'm going to be looking at Module 3, which is Waves and Thermodynamics. I'm going to be answering the syllabus dot points for the new Year 11 preliminary course. So let's have a look here at classifying waves. And you should see a diagram now of two categories: non-mechanical waves, which is electromagnetic waves, and mechanical waves, which are matter waves. And then that has been broken up into two different categories once again. And you'll see longitudinal waves and then transverse waves. So what do they actually mean? Let's go through a few. So mechanical waves, which is matter waves, need a medium to travel. They transfer energy through the movement and collisions of particles of the matter through which they are traveling in. Transverse waves oscillate at right angles to the direction of energy transfer, while longitudinal waves have particle motion back and forth in the same direction as their energy. So you may have done a demonstration in class with slings and ropes, and that demonstrates longitudinal and transverse waves. Let's have a look here at non-mechanical waves. They do not require a medium, and they transfer energy using self-induced electrical magnetic fields at right angles to one another. They travel at the speed of light through the vacuum of space, but slower through denser matter or materials. Because they do not lose energy and inelastic collisions between matter particles, and through the friction due to the particle movement, electromagnetic waves carry energy at much longer distances than matter waves. Now, I've got here an image on my slide which has an electromagnetic wave diagram that's incomplete. Pause the video now to complete this diagram, and we'll discuss the answers in about 3 seconds. So press pause. Okay, let's answer these questions now. So we're going to start at from increasing to decreasing energy. So let's go through it. On the right hand side, or my right hand side, I've got gamma rays, X-rays, ultraviolet, and in the middle visible light. Then I've got infrared, microwaves, and TV and radio. On my next slide, I've got transverse and longitudinal wave. So I'm going to ask you again, if you'd like to complete this before I give you the answers, press pause now. In about 3 seconds, I'm going to answer it. Okay, let's have a look here at the answers. So let's do the transverse wave at the top first. So A is your crest, B is your wavelength, and C is your zero displacement position. D is your crest, and E is your amplitude, while F and G is your zero displacement line. H is your trough, and I is your wavelength, and J is your amplitude. So you should see there they correlate to those positions on the transverse wave. Let's look at the longitudinal wave now. So you got K is wavelength, and L is refraction, M is wavelength, and N is compression. Now, I'm going to have my video on 3B based on these definitions of each of those components. So crest, wavelength, amplitude, compression, refraction. So watch my next video, and it'll be up very shortly. If you're already watching this and it's up, just click the next button in my playlist, and there'll be a video on 3B which demonstrates and provides definitions for each of them. Thank you for watching. If you already haven't, please subscribe, like, dislike. Any feedback is positive feedback for me. So thank you for watching. If you haven't checked out my Module 1 and Module 2 playlists, please do so on my channel. Thanks.